Hey everybody, my name is Kevin Ross and I am a longtime mentor of FIRST, a member of the FIRST Executive Advisory Board, and I would like to welcome you to FRC. The goal of this video is to sort of help some of the rookie teams in the Pacific Northwest get a little jump start. We know that some of you have had weather delays and such. So we're going to spend a little bit of time today talking about ways that you can sort of get your team off and running, and hopefully answer some questions, some of the basics about how to get started. Now, FRC is a pretty big topic. It would take hours to get through everything, but we're going to do our best to get you at least pointed in the right direction and answer some of those questions that a lot of the newer teams end up having about how to get started and where to find things, and just sort of getting over that deer in the headlights feeling. All right, so what we're going to cover today is sort of the yikes what now list. We're going to talk about where to find instructions and help, a little bit about building your robot base, building out your control system, talk a little bit about design strategies and mechanisms in very, very general terms, and then I'll finalize that with where you can find parts and materials. So now we understand that the first year of doing FRC has a very steep learning curve, and we appreciate the fact that you're willing to take this on and to be a member of the FIRST community. Rest assured that the entire FIRST community is here to help. Our greatest ethic is called gracious professionalism. It is a complete badge of honor for another team to help your team get started. So don't be bashful about reaching out to teams in your area and getting help. You're going to hear me repeat that mantra many, many more times because it really, really is the reason that FIRST works so well. Okay, so let's move on and start talking about just sort of the basics of where is it that you can find instructions and help. If you're looking for just design ideas and sort of getting started in the FIRST community, there are several websites that can help you out. YouTube is such an amazing resource for all FRC teams. It allows us to find examples of what other teams have done and are doing. So when you go look on YouTube, you are going to find materials from a whole wide range of sources. Check out Robot in 3 days is a good thing to search for, or FRC 2017. You'll find lots of team videos posted. You'll be able to see what other teams are doing. Really, really a great resource. There's another website. It's called Chief Delphi, and I'm going to bring this up real quick. This is where Chief Delphi is pretty much where, whoops, I clicked on the wrong thing. Let's try that again. Chief Delphi is where most of the hardcore FIRST people sort of hang out, and it is a forum. It is free for you to use, and I really highly recommend that somebody on your team sort of tune into the Chief Delphi area. You'll find out a lot of rumors. You'll find lots of questions to both basic and advanced topics. Great project for one of your students who likes to go online a lot to be keeping track of what's on Chief Delphi. So again, just a really, really outstanding resource for all of the teams, and you'll find people who are literally hang out on Chief Delphi, and they're there pretty much 24/7. So if you ever end up with a question you just can't find an answer to, check that out. All right, so the other places for you to look are actually the FIRST forums. And if you're not familiar with this, the FIRST forums are the official channel to ask questions of the Game Design Committee. The Game Design Committee are the people who came up with the game. They are the official arbiters of all the rules. So if you're trying to do something that you think you're not quite sure whether it's legal or not, or you would like to get clarification on the rules, that's the place to go look. It's really a great resource for trying to parse out some of the rules that you find in FIRST. And so we highly recommend that you go check out forums.usfirst.org. There is if you would like to ask a question, it turns out that your lead mentor, when you log into the FIRST Inspires website, your lead mentor should have a password for the first forums. Okay. Another great resource is actually the First Inspires website. And so let's bring that up real quick. It sometimes is hard to find things on firstinspires.org. But we hope that you will be able to get used to navigating the website. This is the FRC section. You'll find up here on this website the game and season information, and you'll find a whole lot of different resources available to you. Most importantly is the game manual and season materials, and you should be checking this frequently. A quick little tour of this. There's the actual full game manuals up here for you and all of your team members to take a look at. There are field drawings and specifically basic field drawings. That is for you to be able to build some of the practice field elements. Especially for Steamworks, you're going to want to be building one of the hoppers for delivering fuel and for delivering gears onto the field. So and so check out the team versions. This is the one that they intend for us to build out in the field. Basic field drawings, by the way, is the basic drawings for the entire field. The other important thing to take a look at are the team updates. First, usually I think it's on Tuesdays and Fridays, put out team updates. Clarifications to the rules, changes to the rules. Somebody on your team should be tasked with the job of checking the team updates to make sure that you are keeping up with the rules. They do change quite a bit. Here's a link to the Q&A system. Really important that you, if you do have questions about things, to use that. It is a great resource, and you can find really detailed clarifications to the rules. And then, of course, there are a number of other things having to do with the game. Poke around on here. This is a prime resource for you to be able to use. The first website, obviously very, very important to all of us, and something that you really should be having somebody check out for you. Now, the other really, really big resource for you are the local teams, the teams that are local to your area. And I can't overstress this enough, is gracious professionalism tells us that we are supposed to help out the newer teams. That's you. Do not be bashful about asking for help. I will tell you that lower numbered teams have been around longer. That doesn't always mean that they are necessarily pure experts at things, but if you're looking for help, try both the closest team and also if you can reach out to some of the lower numbered teams. There's a great deal of experience in our FIRST community, especially in the Northwest. And so we have some really big powerhouse teams. Some of them actually have fairly high team numbers. Shockwave, for example, 4488 from Portland, or from the Portland area, is one of the premier teams. Apex 5804 from the Seattle area. And the teams are newer, but they're loaded down with mentors who have a great deal of experience and do an amazing job. And of course, Team 360, which is one of the oldest teams in the Pacific Northwest. So there are a lot of these teams that are really willing to step up and help. So please do take advantage of that. And also, if you're trying to figure out which teams are in your local area, see if you can contact your senior mentor. In Washington State, your senior mentor, his name is Eric Van Buren. And in Oregon, Debbie Kerr is your senior mentor, and they'll be able to hook you up with people that might be able to give you a hand. And they're also actually quite capable of answering quite a few of the questions that you'll need answered. Okay? So the other big resource for almost all FIRST teams is andymark.com. This is basically the FIRST store. There are lots of great suppliers, but in reality, the premier FIRST resource for all of us is AndyMark, and that store is made up of very, very experienced FIRST people. They hire first alumni, they hire first mentors. They are so immersed in the first world and so central to the first world that they kind of deserve their own slide. So if you have not been to Andy Mark yet, let me pull up Andy Mark for you just so you can see what's there. They have a very close relationship with FIRST for very, very good reasons. Andy Baker is a Woody Flowers Award-winning mentor, Mark Coors, who just recently retired, but Mark was also a Woody Flowers finalist. You will find you can get every part that you need to build a FIRST robot on this website. The nice thing about this is that you can also go to, say, the base kits, and you can find, they were the ones who provided the base kit, for example, for the chassis. And so not only can you buy the base kit here, but they have wonderful downloads. These folks really do know what they're talking about and know what the teams need. You can get the full assembly instructions, you can get CAD layouts for various things, and pretty much any part that you pick, almost every part on this website has, will have CAD drawings and CAD files that you can download and incorporate into your designs. So we highly recommend, and in fact, I don't know that FIRST would be possible anymore without Andy Mark, so thanks to them. All right, the next thing that you'll want to do is consider, so I know that a lot of you are rookies, and so the big question is, oh my goodness, I've got this big box of parts, what do I do? And how do I proceed? That's sort of an open-ended question, but I'm gonna give you the what would Kevin do, right? So here is the what would Kevin do list, and this is what it looks like. The key is to divide and conquer. There's a lot to be done. Most rookie teams are gonna end up focusing on the robot, but here's maybe my suggestion on how to divide and conquer this. Really, you need to have at least a couple of students and a mentor read the rules and actually understand the rules. FIRST rules are complex. There's a lot of nuance to them, so we highly recommend that you get somebody to be your FIRST lawyer. Get something moving, and so and I'll talk about that in a sec, but there's a lot of things to learn and a lot of things to try. You don't want to put off the assembly of the robot until the last instant. Even while you're still designing the game, you can put together robot base and such. Talk about that here in just a minute. And then make sure that you've got part of your team working on what your game strategy is going to be and helping to design what it is that your robot's going to do. So, so the goal is to sort of leverage the entire group of people that you've assembled, to leverage all of your mentors, to leverage all of your students, and see what you can do about dividing and conquering and making this easier to put together. And again, you will start down a few paths and you'll have a few stumble steps. Doing things early, getting some experience early, just super, super duper important. I think you should also consider setting your expectations in a rational way. This is my 18th year. This is my 18th season, and I'm very, very confident in the advice that I'm going to get you about setting your expectations. Goal one is to get something that removes around the field reliably. If you can drive around the field and not break down and not fall to bits, your students will have a much better experience, and it leaves you many, many more options. So that goal is really the mobility that's going to allow you to do everything else. So that is your number one goal, is to get something that moves around the field reliably. Then find one of the functions to do and do well. Make sure that you can do one thing very, very reliably. And then goal three is try really hard to make sure that you can do something in autonomous mode. The way FIRST works is that you are going to be scouted and evaluated by other teams to determine whether you make a good alliance partner. And so what we really want you to do is to be able to show people that, hey, you've got your act together. So if you can move reliably and you can do one thing well and you can move in autonomous mode, you will be surprised at how far you can get with that. And then the fourth goal is to start adding functionality in steps. I wouldn't jump from being able to do autonomous mode to trying to score every possible point. Key thing, it is not possible for you realistically to be able to do everything on the field. And the games are designed that way. There are a few teams in the world that get away with that, but most of us end up specializing in some form or fashion, okay? The next part is, and let's talk very, very explicitly about this particular game. I would really suggest tackling things if you're not sure where to start and you feel like you need some help getting started. Highly recommend that you start out by being able to move autonomously across the baseline to score in autonomous. So that there's a tape line. It's maybe I think it's about 8 feet or so. I don't know the exact dimension away from the starting wall. If you can cross that in autonomous, you've scored and you're now contributing to your alliance. Okay, and it isn't a terribly difficult thing, but don't put this off to the last instant. You'll probably want to be able to do this right away. Okay. I would also be able to score with the gears. As with all first games, there are a lot of different options for scoring in this game. Some of them are easier than others. I would highly recommend that you kind of start with the gears. And they are a high value item. If you are able to contribute to your alliance by helping to deal with the gears, I would leave the processing of the balls to a team with a little more experience. By no stretch of the imagination am I telling you not to try to deal with the balls, but I would definitely make sure that your robot can handle the gears reliably and consistently. That makes you a great alliance partner. And quite frankly, dealing with the balls in a meaningful way where you can actually score a lot of points with them is a bit more work than most rookie teams are probably going to be able to handle to be really reliable at it. So my key thing here is to make sure that you have a shot at being on a winning alliance, all right? I think the third thing that you should do is really focus on being able to climb the rope. It is a high point activity. 50 points, if you were to sit down and calculate the number of points that you can get by messing around with the balls, it turns out that 50 points is a lot of points. Now, there are going to be really good teams who are going to try and deal with the balls because of ranking points. Let's have you focus on things that you can reasonably accomplish and do very well and do very reliably. And I think if you were able to drive around, do the gears, do autonomous, and climb, you're going to make an excellent alliance partner. Okay? So if you can swing it and you would like to try it, as long as you can do those first three things reliably, go ahead and try messing around with the balls. It's a great addition and it's a great skill. It is a wonderful problem for your students to have to solve. I think that even if you were to go with something relatively simple and straightforward, like going over to a hopper, dumping a load of balls onto into a basket or a platform on your robot, drive over to the low goal and dump them in, I think that'd be cool. And I think that it's something that you should be able to handle and you should be able to get working relatively easily, and it will add value to your team. So I think it's a great idea. But don't do that at the expense of the previous three things. I think that's really where your point values are going to come into play. Okay, one of the most critical parts of being part of FIRST is realizing that you are not alone. You are working on a team, and so being a really reliable alliance partner actually goes a long way to giving your team a good reputation and for you to advance on. And so reliability really is the key to that. If you're able to score reliably and you're able to function reliably, the other teams will take note of that, and the other teams will find your team to be valuable. Okay? Cool. So let me talk a little bit about the rules, because the rules are really important. The rules spell out a lot of details and a lot of restrictions. Pay attention to the restrictions. There are restrictions on size, there are restrictions on weight. So you really do need to have somebody read through all the rules so that you're able to actually play the game and pass inspection, okay? When in doubt, take the wording very, very literally and very seriously, because each one of those rules usually has an inspection or or somebody watching out for those, okay? Your robot, before you get to play, will be inspected for size, for weight, for its configuration, and the gameplay is also monitored by referees. So don't feel like you can sort of go, oh, that doesn't seem like a very good rule, we'll ignore that one. It really won't work out to your advantage. Now, let's talk a little bit about size and weight restrictions, because this is a big one. For as long as FRC has existed, there have been rules on the maximum size and the maximum weight. And we are really sticklers about this, especially the weight. If you weigh 120 pounds and 1 ounce, we will tell you to go get rid of 1 ounce, right? And so you have to pay particular attention to that weight thing, because sometimes it's difficult to lose a lot of weight. I remember I think it was in 2009, we had a rookie team show up and their robot weighed 180 pounds when the limit was 120. And we literally had to cut the entire top of the robot off, which it was a really cool robot, but they saw that weight rule and somebody sort of remembered it, but didn't really think that much of it. We are real sticklers for the weight as to plus or minus an ounce, okay? So keep that very, very closely in mind. And same thing with the size. In this game, there are two potential robot volumes, they call it. And so you need to pay attention to the robot volume, which includes the bumpers, but also pay particularly close attention to the starting parameters, the starting conditions for the robot. You have to be within within a certain frame, your frame perimeter. You have to be within your frame perimeter. I'm not going to try and explain all those rules, but pay close attention to the difference between a frame perimeter and a robot volume. You must start within your frame perimeter. Your robot, after the beginning of the match, should be able to grow to fill out the volume. But these are the kind of rules, these are the rules that usually get most people into trouble, and they are the most difficult to modify while you're at an event, okay? So if you have any questions about that sort of stuff, find a team close to you, or reach out to your senior mentor and see if they can help explain it to you, and also check with the game design committee. It is fairly well specified in the rules, so definitely have a look at the rules for that, okay? So, I got a little switch here. Let me highlight a few of the rules for you to pay close attention to. Robots are required to have bumpers, and there's a big section, in fact, there's an entire section just dedicated to bumpers. And we have problems with teams every year not adhering to the bumper rules. Please understand them well. Be sure that you've read up on them. Very, very important. Another one that usually gets people is wire sizes, and there is a chart. There is a chart in the rules that specifies wire sizes. And yes, for all of you electrical engineers and electricians out there, the wire sizes that we specify are larger than what the NEMA codes say. On purpose, okay? So we haven't had any robots catch fire in a number of years. We want to keep that going. The wire size rule is very, very important, and we acknowledge the fact that, yes, you could have used a smaller size wire, however, you can't because of our rules. So do keep that in mind. The other thing that we want to call your attention to is Rule G04. It's in section 7.2 of the manual, and it has to do with this size thing. So definitely check out that section of the manual, or you will be relatively unhappy when you show up at an event. Okay? So I would highly recommend that if you haven't yet, get something moving. When things are moving, the team sort of will start to click, and it sort of releases the creative energy. Before anything is moving, if you don't have anything yet, this whole thing is just sort of a mental exercise. Once you get a robot moving, people can start to play with things. They get a sense of the physicality of things. Really, really important. So you should have probably gotten a robot base. It's an Andy Mark kit. And you should have gotten instructions. If not, if you go look on that Andy Mark site, and here I'll bring it up again. If you go up here to the Andy Mark site and you go to base kits and you go to the AM14U, this is the kit that they shipped out this year. You will find instructions on how to put it together right here. There are also instructions here on how, what you need to order, what you need to do to modify the size. If you haven't come up with a design yet, I would highly recommend just putting together the default size kit. I will tell you that there are 3 configurations for it. There's the standard one, there's a wide configuration and a narrow configuration. So you can see them change there. So this one's wider and this one's longer. I hope you can see the difference there. If you wish to switch your wheelbase so that the wheels are at different dimensions, you can do that, but you'll end up having to order new belts from Andy Mark. Not a problem. People do that all the time, so don't be afraid of doing that, but it is something that you'll need to keep in mind, you're going to need to allow several days for that because they need to get shipped from Andy Mark, okay? And again, try not to cut anything. And then assemble the control system. So once you get the base together, you'll have some motors and stuff. Try not to cut too many of the wires yet, because you really don't know on your production robot what it's going to look like. But honestly, what we're trying to get you to do is to assemble this thing to get something to move so that the kids can play with some stuff, okay? You're going to need some plywood, by the way, to mount the controls on. So if you're watching this and are thinking that you're going to get this done, go to Home Depot or somewhere like that and find yourself, I think, a 24 by 36 chunk of 1/2-inch plywood ought to work. Okay. Now, the other issue comes up is what programming language to use, and so there are a number of choices for programming languages, and I have quite a bit of experience with software, and I will tell you that LabVIEW, which is one of the options, is really a remarkable setup. It's a remarkable environment. However, it is not as straightforward to learn as the others. Once you learn it, it's incredibly powerful, and so I don't want to disparage you from using that. But if you're just getting started, most of the teams have actually moved to Java. Java is a very common language. It's sort of a cousin to C and C++, and people are mentors will be more likely to be able to help with Java than they will with LabVIEW. So if it was me, and again, this is a what would Kevin do, I would recommend that somebody on your team figures out how to set up Java. Now, if you go to the first website, you will find, going to the first website, you should be able to find, under technical resources, you'll find a whole bunch of stuff under here. One of them is electrical and software resources and the control system programming document. I'm going to just bring this up real quick. They are trying something new this year, and they have a getting started with guide and a lot of specifications on things up here. And it's really well done. The getting started guide, I'll click on this. I find is a little bit confusing because I wouldn't organize this myself. They're going to tell you new things and all this stuff, and the reality is that somewhere down here a little farther is the actual getting started part. The rest of this, they're going to tell you about a bunch of features that are going to sound like, well, they just sound like gobbledygook, honestly, if you don't know what they are. So there is a spot in there where it tells you how to wire up the control system. There's another spot in there that tells you how to install Java and how to get things up and going. So highly recommend that you check that out. And again, that was this is on the first website, or I got a link to this from this first website from the resource library. And I think actually there's a more direct link to it in here somewhere. I'm not sure where that is. Okay. So get something moving. By moving, the reality is that, the robots are teleoperated. So you'll have a joystick or something. You'll be able to drive it around. It will totally jazz your students. It will sort of get them fired up and realizing that, hey, this is something they can do. I would expect this to take somewhere between 6 to 10 hours to really actually get completed, because you're gonna have to go find stuff and download stuff. So this is probably a couple meetings worth. The base you should be able to put together in one meeting. If you can split your team in two and have half of them work on the controls, half of them work on the robot base, and sort of follow these guides, you'll probably be able to knock that down to 4 or 5 hours. Okay, so that's a great way for you to get started. Let's talk about design strategies. And there are a number of strategies, and so I'm going to keep this a little bit high level rather than going into exact specific detail. But really, honestly, keeping it simple is really important. Reliable robots that can do the same thing every time, they tend to do better. Whereas these high-risk, high-reward robots, the ones that are shooting for the moon or doing something that's that if it works is going to be super, super cool and awesome, but the chances of it actually working are somewhat limited. When they do their cool thing, the crowd will go crazy, but for the most part, those tend not to actually move on or advance really well. So, building a robot is complex enough. Why make your job any harder than you have to be? So I would try as a rookie team to keep things somewhat simple. I think another really important thing is defining a strategy before you start building. The students will inevitably want to jump right in and start building and cutting stuff, and that's 100% natural and fun and good. I'm with that. But along with that, a little bit of process can actually help your team go a long way. And so if you can define a strategy of how you would like to play the game, that will allow you to do things like determine some metrics about what is good and what is bad, and start to so your strategy will inform: is your robot wide and short, or long and narrow, or taller or shorter? Remember, in the guide, in the rules, there are 2 different robot volumes you can choose. So your strategy, if you know how it is that you're going to play the game, that will help inform your design. And so I really highly recommend coming up with a strategy. And it doesn't really take that long. Go through some of the point scenarios, play the game in your head, figure out some things like that, and that will kind of get you up and going. It will also define some numeric metrics for your team to in terms of the size of the robot, or in the number of points, or in the heights of things. That these metrics go a long way to helping you design things. Okay. Part of the game strategy is actually figuring out what's important and what isn't important. This game, for example, it turns out that we have these things called ranking points. Ranking points determine your ranking as an alliance. So your entire alliance, when you're competing, if you win, you'll get 2 ranking points. If you lose, you get 0 ranking points. And if you tie, you split the 2 ranking points. So each team gets 1. And the teams with the most ranking points at the end of the 12 rounds that you play at your district events, those ranking points determine who gets to be the alliance captains. Now, you can earn additional alliance ranking points by accomplishing certain things on the field. And these extra ranking points are really, really important. And actually, even if you end up losing your match, you can still gain that very valuable ranking point by achieving the goals. And the 2 big ones are getting enough steam pressure built up in your boiler, and then I think the other one is to get enough gears up on the airship in order to be able to turn all of those wheels, right? Both of those earn you ranking points. Those ranking points are critical to your success as an alliance. So there are maybe a trade-off to be made for points versus ranking points. Keep that in mind. It isn't obvious as you read through the rules what the importance of the ranking points are, but they're way up there. So keep that in mind, okay? Important part of your strategy discussions. All right, we only got 2 slides left. So when it comes to actually working on your designs and coming up with mechanisms, really honestly, YouTube is your best friend on this one. They do, you'll find teams have shared amazing designs. There's a lot of history. Really highly recommend taking a little bit of time to go check out YouTube, look at what other teams are doing this year, look at what other teams have done in the past, okay? Also, you'll find up there, one of the joys of going and rooting around in YouTube is you will find up there a number of resources and a number of standard designs that people have worked out over the years. So these standard designs, there are very common designs for dealing with balls, there are very common designs for throwing balls. These are time tested. There are also designs for robot chassis and control systems and those sorts of things. Take a look at that. Really useful thing to do is to spend a little time on YouTube. I would do searches on FRC. I would do searches. You can do FRC 2016, 2015. So take a look at that. I think the other sort of high level point I'll point out to you is your mechanisms need to be durable. Your robot will get knocked around during the game. Heck, your robot may even fall off of the rope while you're trying to climb. So make sure that your mechanisms are durable, and that keep that in mind as you're designing things. If you're putting out a nice little, if you're coming up with a mechanism that is thin and paper thin and sort of reaches out or does something along those lines, or it's probably not going to last. If you should be able to shake your robot or run your robot into a wall and nothing should break off. That's sort of the bottom line to the whole thing. So keep that in mind, all right? Another really important thing to keep in mind is that our experience over time tells us that driving the robots is harder than it seems, and so you need to be sure that you're not trying to set your drivers up so that they need to be exactly dead on, like within a couple of inches, to make a mechanism work. It doesn't work that way. I would go like plus or minus 3 inches. So you need to have like a 6-inch variance or a range for teams to be able to, for the drivers to actually complete some tasks. Remember, they're driving a robot that might be as far as 54 feet away and behind something, right? So expecting them to be able to line up exactly on something at that distance is probably a little unrealistic. And so keep that in mind as you're trying to design things, all right? There are a bazillion different design options for how to play this particular game. No way for me to go into all of those in a video that's less than about 10 hours long. So I'm trying to be done here trying to squeeze in under 45 minutes on this particular preliminary video. So be sure to reach out to other teams to find out what they're doing, and most FIRST teams are very gracious and will show you exactly what they're doing, and they will also show you the designs for exactly what they're doing. All right. So now the last thing that we want to point out is where to find stuff. You're going to have to buy some stuff. That's how it works. Andy Mark, we've already talked about at great length. All things FIRST come from Andy Mark, and they are really the prime resource for FIRST teams. There are a couple of others. One of them is McMaster.com, and the other one is MSC Direct. I'll just show you these guys real quick. I'm just going to use McMaster, but it turns out that these guys are actually competitors, and they carry a lot of the same stuff. McMaster is an industrial supply company. They are really great at getting things to you in a hurry. They have an enormous inventory of stuff. So say, for example, you go down to power transmission. I mean, if you're looking for bearings or shaft collars or sprockets or chain, this is a great place to find stuff that you really have hard time sourcing locally. And so if you're, and the other nice thing is, let's go with, here, we'll go find a bearing, and they have all kinds of different bearings like sleeve bearings, so, or ball bearings. So we'll go with a ball bearing, and they have, you know, just normal light duty ball bearings. You can come in here and check out, they have a whole range of sizes, and you can narrow your selection down. By the way, if you do buy ball bearings, make sure and get sealed ball bearings because you don't want to get dust and stuff in there. Here we'll pick one that has a 1/2 inch diameter, so you'll be able to buy them. The other cool thing is you can actually click on here and find product details. So they'll show you very nice detailed drawings of what's here. I think it might be down here. And right here, you're also able to download CAD models for it. So highly recommend. McMaster Carr is really good at that. MSC does as well. They don't have quite as nice a setup for finding CAD drawings, but hey, you know what? They work pretty good. And amazingly enough, you can buy in a really great number of things on Amazon.com. Amazon.com is really cool, mostly because if you have a Prime account, shipping is oftentimes overnight for free. One of the harsh realities of doing FRC is that you spend an incredible amount of money on overnight shipping because you sort of need stuff the next day or the day after. And you can oftentimes find things for a pretty reasonable price on Amazon.com. They are partnered up with Stock Drive Products and I think Small Parts and several other industrial folks. Honestly, I usually, if I know that I need to order something, I'll at least poke my nose over at Amazon.com to see if I can get it and if I can get it delivered overnight for using my Prime account. Okay. Now, I'm gonna wrap this up here, and what we'll do is we'll actually have a live interactive session. I just wanted to get these basics out to you so that hopefully you've learned something here. Hopefully I've maybe provided you with a little bit of direction of where to head. We will do live question and answer sessions that you can call in using GoToMeeting or GoToWebinar, and we'll try and answer whatever questions that you might have. So this first year, especially for our rookie teams, this can be a real challenge. Everybody who has done first has gone through their rookie year. Don't sweat it. Do your best. Ask for help. Always come to an event. Even if your robot isn't quite functioning right, put it in the bag, bring it on in. There are teams around you in the pits will help you get up and going, especially if you reach out to them beforehand. It's our goal, it's our collective goal to make sure that your team can succeed and thrive in the FIRST community. So on behalf of the entire FIRST community in the Pacific Northwest and actually nationally, we welcome you to FIRST. I think you're going to have a great time, and we look forward to hearing from you and answering any questions that you might have. With that, we'll call it a night. Thanks.